Hi, I'm Brian, the NDT Services Manager here at MagnaFlux. This video is going to give you a demonstration of the basic inspection process using the wet fluorescent method. The actual process you use will depend on your ASNT Level 3 or your Cognizant Engineering Officer. The first step in the magnetic particle testing process is to ensure your part is ferrous, which means it has to contain iron so that we can magnetize the part. The next step is to actually physically clean the part prior to testing. This will remove any oils and greases that are on the part so that your testing is much more effective. A very simple, easy way to do it is using MagnaFlux SKCS cleaner. Spray the part completely, and then wipe off any grease and oils that are on the part. There are other methods suitable for cleaning the part. Prior to testing the part, you must check a couple things to make sure your machine is actually ready. One is the ultraviolet light concentration using a UV meter, the visible light, so you have less than 2 foot candles in your inspection area, and you also must check the bath concentration. I'm going to show you how to check the bath concentration now. We'll need a centrifuge tube, the one appropriate for the particles and fluid you're using in your bath, and your pump has been running. You run fluid through your bath hose until you get particles coming out. And you fill the centrifuge tube up to 100 milliliters. After that, you place the centrifuge tube in a stand and let it sit. If you're using an oil bath, it has to sit for at least 60 minutes. If you're using a water bath, it is only for 30 minutes. And then you read the concentration. You also must check your bath for contamination, called dirt. You're only allowed 30% contamination. If you have that much contamination, you need to change out your bath and clean your tank. And now we're ready to test the part. We'll place the part between the headstock and tailstock, and then clamp the part. And ensure that the part cannot be moved. This will prevent arcing between your copper pads and the part itself. The next step is set the machine up for a contact shot. We're going to be doing a standard wet horizontal inspection process, which means we'll do the contact shot, inspect the part, coil shot, inspect the part, and then we'll demagnetize the part. I'm using a multi-directional unit for this video, but I'm using it in the standard mode. The actual amperage that you will use to test the part is determined by your level 3 or your process instruction. There's multiple ways to determine the correct field. You either have to use a digital Hall effect probe, a QQI, which is a steel shim with an artificial flaw on it, a known part defect, or a magnetic flux indicating strip. One of those methods have to be used to ensure the current is correct. Then you can use the ammeter on the machine as a reference point. So now that we have the part clamped in, we will weight the part, and then we will apply the magnetization current right as I stop the bath flow, such as follows. I weight the part sufficiently. Anytime the particles are still moving freely on the part, I apply the magnetic current. Now you heard 2 pulses of mag current on this machine. The ASTM standard says we're required to do 2 mag shots on each part. Machines that we shipped from MagnaFlux in September of 2015, this is an operator selectable option. So it does 2 mag shots automatically, and that's on all wet horizontal units that we sell. Once you have done that, then you would inspect the part for any defects. To inspect the part, you may actually have to unclamp the part and physically look at it to see any defects. And depending on the part geometry and configuration, we'll inspect all areas. Once that inspection is done, you can place the part back into bring the coil over into position. The rule of thumb to remember is, on a contact shot, you will see indications in the direction of the magnetic current flow. In this case, it's going from the headstock to the tailstock. But you will not see indications that are exactly 90 degrees perpendicular to that current flow. This is why we have the coil shot. So now we move the coil into place. And the coil is good for coil field, is good for 9 inches on either side of the coil. So effective part area is 20 inches. So if you have a part over 20 inches long, you need to move the coil and form a second, third, or multiple shots until you cover the part. The technique is still the same. You make the part and apply the current just prior to stopping or as you stop the backflow. And then you would inspect the part. All right. You can see clearly that I have a field established in this part. So now after I run the demagnetization cycle, we can check and the part is now demagnetized. Once the part is demagnetized to your specifications, the normal specification is less than plus or minus 3 Gauss. You may then take the part on to continue processing it.